sense. And tell me again, what did you say? It's sim. I'd heard the expression sim soup, but explain that to me one more time, because you kind of, the internet connection went in and out just then.
The sim soup stands for simulation supervisor. This was the person who was organizing each of the mission sims and was adjusting them in real time to provide the maximum amount of stress on the flight controllers and on their support personnel. And believe me, if you were ever in one of these mission sims in mission control, it was as if you were actually flying a mission. People were getting very emotional about the whole thing, and it was a tremendously important exercise. And the simulation supervisor, or sim soup, was one of the unheralded heroes, I think, of the Apollo program.
Thank you. I just wanted to make sure I captured that, because that was a great description of that. And I think you're right. The first time, actually, the last person who spoke to me about it was Charlie Duke. And I think you said diabolical, and I cannot remember the adjective he used, but it was equivalent of the sim supervisor.
Well, they certainly got your attention, and having participated both in mission control and as a crewman in many of these simulations, I was on Apollo 15 backup crew as well as the Apollo 17 prime crew. You can figure out how in the world it got everybody organized and disciplined to solve problems.
That's, I have to say, though, I'm grateful that I don't have to go through that in my career. I think the stress as it occurs is quite enough. I can't imagine having anyone make up new ones. Oh, goodness. All right. Back to museums, and then I want to go back, and I'm going to ask one more question over, because I can kind of see how our recording is going and the internet is causing us just a little bit of trouble, but I'm going to keep going for right now. We talked a little bit about Early's museum and ours, but if you could tell me again what you think the role of museums is, and if you have anything that you would say to people who are on the cusp of deciding with their charitable dollars whether or not museums deserve that attention.
Well, the Cosmosphere is one of the many museums in the country that specialize in air and space displays and education. Their museums in general provide a record of how dreams come to fruition, how the heritage of various parts of American history are displayed and can be viewed. They're extraordinarily important in this day and age, particularly in providing that kind of background and education for young people. The Cosmosphere itself, of course, has the Apollo 13 command module on display. That was probably one of the most successful missions we ever had, when you consider it in its entirety, the rescue of the crew of Apollo 13. Having that capsule there at the Cosmosphere is a unique opportunity for young people to realize what it takes, to learn what it takes in order to operate in deep space. Today, we tend to forget that deep space has its own set of risks. They are no different now than they were during Apollo. Nearer space is starting to become a little more routine, but deep space hasn't changed, and it will never change, because those risks are inherent in the fact that you're long distances away from Earth and in a very, very unique space environment. So there's a great deal for young people to learn, for the future flight controllers to learn, for the future astronauts to learn by the kind of work that you do at this Cosmosphere, and particularly in in illustrating the heritage and the dreams that people have had. You've got to realize that over 400,000 Americans were involved in Apollo, and that not only were they involved, but their families were involved. So it's a tremendous legacy that you have at the Cosmosphere, and it is present in many museums throughout the country.
It's interesting. I don't know if you're aware, but at Wichita State University, they have the College of Human Performance, and they're actually working on parts of the new spacesuits. I think many different universities are. But we think now about the ergonomics and even comfort to some degree. And I don't know that going to space is ever going to be entirely comfortable, but when I look at the suits that you wore and the quarters in which you lived for the time that you were there, none of it looks very comfortable to me. And I understand that the suit had its limitations. So talk to me, as you spent so much time really working hard on the lunar surface. What was that like?
Well, the spacesuits we had, they were known technically as the A7LB pressure suit. They were really quite remarkable for their time. Not remarkable in how they were made in Delaware with sewing machines and seamstresses who did a wonderful job. They were custom made, and they were particularly comfortable when pressurized. Unpressurized, it was 80 pounds resting on your shoulders. So you can see that the suits were most comfortable when you were actually in them and pressurized and working. The only major problem with the A7LB spacesuit was in the gloves, in that they were pressurized at 3.7 pounds per square inch. And so anytime you wanted to pick something up, you had to work against that pressure. It was, and that exercised these forearm muscles and caused, if you didn't slow down, caused excessive fatigue in those forearm muscles. So that was the issue, primary issue with the A7LB in efficiency and actually working in the suit. Interesting that the cabin of the lunar module was just the opposite. It was most comfortable when you were out of the suits. When you're in the suits, it's like having several more people in that cabin. It was crowded, and that was the most difficult part of working and preparing to go outside on the lunar surface. Was getting ready, getting suited, getting pressurized, testing the suits before you went out and the like. So the cabin was very different than the suits themselves. The suit really was another spacecraft. It protected you. It had an environmental control system. It had mobility because the human being was inside the suit, and it had communications, power, everything that a spacecraft has to have. It just had a limited life expectancy, if you will, in that after about 8 hours, you needed to be back into the cabin and pressurized again. The new suits that they're working on, it's called the XEMU, extravehicular mobility unit. I'll get that right. They apparently, although somewhat heavier, have really improved the mobility of the joints. They're very different joint systems, and so that apparently will compensate for the fact that they're slightly heavy. They're somewhat heavier. The main issue that is being addressed by many people right now is how do you keep dust off that suit so you do not bring dust into the cabin after an EVA. And that is an issue that a lot of people are working on, including myself. And we just are going to have to figure that out. The suit is the primary way that dust comes into the spacecraft. And we just need to figure out a way to keep it off the suit so it never gets in the spacecraft. And we'll see. I think they'll probably work that out.
And for our viewers out there, explain what is the problem with dust or crumbs or any small items in a spacecraft.
Well, it turns out that in Apollo, on Apollo 17 with 3 EVAs, actually Apollo 15, 16, and 17 had 3 EVAs out onto the surface. We brought a lot of dust in the cabin, but on the other hand, there's no evidence that it ever was a problem in the cabin or with the human being. We breathed that dust. After about 7 minutes, we took the helmets off after each EVA, and you could smell the dust. It smelled like gunpowder. Matter of fact, everybody had the same impression of the smell of that dust. It's the kind of thing that you don't want to breathe forever. We know that here on Earth that certain kinds of dust will cause significant long-term and chronic problems, lung problems, respiratory problems. There's no evidence that the lunar dust ever caused those problems. Now, we might not have run all the physiological tests that could have been run to determine that, but there is no evidence at this time that that happened. But on the other hand, you just, as you go for longer and longer missions, more and more excursions out onto the surface, you don't want to expose crews to that dust in a chronic way. And so that's an important issue. It can be a problem with electronics and stuff, but you can seal electronics, you can seal bearings and things like that. The primary problem we had with the dust was in the connections for tools. We would have quick disconnects for the tools, but eventually the lunar dust got in there, and after an excursion and a half, those connections were not working very well at all. And so that is something that they're going to have to work on. Again, if you're going to have numerous excursions, numerous EVAs, and a lot of activity on the surface, is to keep dust out of moving parts. Dust is an issue, and keeping dust off the suits is something that needs to be worked on, and hopefully these young people will come up with some great ideas about how to do that.
That's right. I hope so too. Now, I'm sorry to have to ask you to repeat yourself, but I'm carefully watching my recording information here, and it looks like about when we were talking about your time in college with the international community and responding to Sputnik. Can you just repeat that for me? Do you mind? What Sputnik meant to you and your colleagues?
It may not be exactly the same, but...
That's okay. I just don't want to miss it. It was really an interesting insight.
My primary interest in space began when I was a Fulbright student in Norway. I happened to be out in the field listening to the shortwave radio, Voice of America, coming out of Tangier, as a matter of fact, late at night, a little after 11, when the news came on, and I heard about Sputnik being launched. It did not, it was interesting at the time, but about a month later, I was back in Oslo and had a chance to talk about this with the international student community who were in residence at the university, and they were extremely concerned. They were excited about the fact that space was starting to open up, but they were very much concerned in those days of the Cold War that the Soviet Union appeared to have a dominance in technology over the United States, who, in spite of everything that they might have said and the criticism we had, was still viewed as the protector of the free world, and was indeed the protector of the free world, and is so today. And so I became increasingly interested in the historical impact that space might have. However, I didn't really consider getting personally involved until I had completed my PhD work at Harvard and had a chance to start looking for a job, and realized that the United States Geological Survey was working for NASA on many space-related geological issues. And so I got in touch with Gene Shoemaker, who had organized the branch of astrogeology in Flagstaff, Arizona. And it turns out he was trying to get in touch with me at the same time. And we came to a meeting of the minds, and I went to work for him on space-related issues that had a geological context to them.
Do you have anything else that you'd like to say? Have I missed hitting anything that you think people should hear?
I just want to, again, encourage people to support the Cosmosphere. It is one of the more outstanding, it probably is the outstanding museum in the United States for space and air related issues. And it's something that you can do to really benefit future generations. These museums will continue to be around for a long time, well past our time, and they do, in fact, contain the dreams and the heritage of hundreds of thousands of people and what they have tried to do and, in fact, accomplished in space as well as in aeronautics. So I encourage people to support you. I hope it goes very, very well. And I look forward to being there in person, not too distant future.
Okay, well, thank you so much, Dr. Schmitt, and you have a wonderful rest of your Friday.
All right, take care of yourself.
You too. Bye-bye.